Ha! Ha! Yeah! Ha! Ha! Yeah, baby, yeah! I got the money. Oh! That's okay, man. That's my toilet paper. Yeah! Yeah, I got plenty to burn. Welcome to Money Math. Intro to proofs. Dollar, dollar bill, y'all. Yo, we're gonna throw money at this problem. So! Where's my marker? Oh, there you go. I bought a new marker, yeah. All right, let me hear you one time. Yay, math! Yeah! All right, let's go. Let's do some math. Money for later. Dinner's on me for life. All right, where's my... here we go. Okay, so I'm going to suspend the accent for the lesson. Welcome to proofs. No, but for real, in all seriousness, joking aside, thank you. This outfit was supplied by the students. So thank you. Give yourselves a hand. Yay. All right, cool. And it's perfect because we're going to do intro to proofs. Proofs is probably the hardest thing, traditionally speaking, in geometry. All right, so we're going to start it off really strong today. Thank you for the outfit, right? Yeah! And I hope that after today you have some idea of what proofs are about, all right? So let's jump right into it. First things first, we need to know our properties, okay? So if you're looking at number 1 on the sheet, all right, you see that if 80 equals measure of angle A, then if 80 equals angle A equals 80. Does anyone know what property this is mathematically yet?
Reflexive?
It's almost reflexive. It's not. Reflexive would be A equals A. Okay, yes?
Commutative.
Commutative would be A plus B equals B plus A when you move them with a plus sign. Yeah?
Transitive.
Nope, it's not transitive. Not transitive. Yeah.
Symmetric property?
It's the symmetric property. Yeah. Symmetric property is if A equals B, then B equals A. Or, you know, so notice you switch over the equal sign. Right? So you can write that. Symmetric property. Okay, the next one's very relevant. It's going to come up a lot. RS. Ha! RS equals YP. Okay, look at that one. You see the link? RS equals TU. TU equals YP. So now we connect the beginning and the end. I heard it earlier today. Yes, sir?
Transitive?
Transitive property, right. Right. Transitive property is when you start at the beginning, you go to TU, TU connects to another, and then so we connect beginning to end. All right? So keep that in mind. It's going to come up again. Next one. 7x equals 28. So x equals 4. Now, here's the question about proofs, all right? Try to understand the following. What changed from this statement to this statement? What did we do algebraically? Yes?
We solved it.
We solved it by doing what?
By
Yes?
isolating
Division
x.
property.
Yeah. By isolating x, by doing what?
Division.
By dividing both sides. So this will be division. So the way you want to start thinking about proofs is, what did I do to get from here to here? I used division. I divided both sides by 7. Okay, moving on. Now here's something that may...
So which one's this called? Division.
Division. That's right. All right. So now give this one a shot. All right. So check it out. VR plus TY. VR plus TY equals EN plus TY. And they have VR equals EN. That's a funny N. I'm used to writing M's for money, not N for nothing. Yeah! Ha! Got my money. Ooh! This is like edible, by the way. Okay, what changed from here to here? What changed? Notice this statement. Notice this statement. What went away? Yes, ma'am.
Well, you subtracted the ty from both sides.
So this would be the what property?
Additive.
I don't know.
No, no. You said it yourself. Yeah, you said it already. Subtraction. Yeah, subtraction. Additive inverse, I know what you mean, is like what you add to make go to 0, I suppose. But this is just from here to here, the difference was ty was subtracted. All right? So that's the idea with that. And now, one more, and then we'll get right into the proof. We'll do an algebraic proof for the first time. So we have angle 1 equals 30. Angle 1 equals angle 2. So, okay. Let me ask you a leading question. Why is this not transitive property? Yes?
Because you didn't take out the last part, you took out the first part.
Okay, I understand what you're saying. You're saying that because 1 equals 30, so we'd have to do like 30 equals something for it to be transitive, right? Like the train, I like to call it the train. The train would like to go, would like to continue. 1 equals 30, thus 30 equals something, and then 1 would equal that something. But this is not transitive property, you see. This is like A equals B and A equals C, right? So does anyone have any guess, or maybe you've heard back in the day, what this property would be? Follow up?
No,
Yeah?
don't you mean angle 2 equals 30?
Yeah, 30. That's why I meant 30. Sorry. Thanks. All right, good. Okay, I'll explain. This is probably one that you're going to see most of the time. All right? Would you agree that this statement with the star here is the same as this statement here, with the exception of the 1 and the 2?
Yes.
Yeah.
All right? So then would you agree that this is the exact same as this, except we took this out, and in its place we put angle 2?
Yes.
Because 1 is equal to 2.
Mm-hmm.
So when you take something out and put something in its place, that's called substitution. Okay? So that's a property that's going to come up a lot, substitution. And just in your best interests, maybe not mine, but I'll say it in your best interests, if I was your cousin or your tutor or something like that, and I was helping you with this stuff, I would tell you that if you're taking a test ever and you don't know what property it is, try to just put substitution. Chances are you may get it right. All right? So I'm just letting you know that. Substitution happens a lot when you take something out and put something in its place. All right. So let's take this one now and do our first algebraic proof of life. Okay, so here we go.
Hopefully the last.
Oh man, that's wishful thinking. You got a lot of proofs in your future.
Money can buy anything.
Money can buy fantasy, you know, the fantasy of no proofs. Prove x equals 1. Okay. Statements. Reasons. Okay, here's how it goes. Here's how it goes. Has anyone ever done a proof before? Yeah, a couple people. All right, 2, 3 people. All right, here's how it goes. We start with a given statement over here, and then we write reasons justifying those statements, and we work this down until we get to what we're trying to prove. So the first statement is always what's given. So let's write that in. 8x minus 5 equals 2x plus 1. And this reason means what gives us the right to know that this is true? Where do we get this from? Yes?
Because it's the given.
It's the given. So given goes here. And by the way, the first reason for the first statement will always be given. So that's like 3 points on the test. This will always be given, the first one. It's always funny to me, or sad, more sad, but kind of funny, that when I gave tests in years past, I would get entire proofs, and all I would see was given. It's that's all they knew, you know. And I was like, money. Yo, you gotta do better in your math. Here's a $100 bribe. Woo! Save it for later. Some people tip 15%. Some tip 20%. I tip 1,000%. I buy the restaurant. Yeah. 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 Okay, back to proofs. Okay, so here's how it goes. Remember, I said before that the paper may not be exactly the same as what I do. But let's start you off. What would be the first thing you do in solving an equation like this, algebraically? You know, like in algebra last year. Yeah, what would you do?
Put the x on one side.
Put the x on one side. So what would you do to both sides?
Either plus or minus. Minus them by 2x.
Okay. So let's subtract 2x on both sides. What would the result be of subtracting 2x from both sides?
Subtraction.
No, what would the result be? Yes.
6x minus 5 equals 1.
Right on. 6x minus 5 equals 1.
Good. So that means you could skip the one step that they're doing.
Right. In the paper, just for people watching this, they have a lot of substitution stuff added, right? They basically have, like, you see minus 2x on both sides, all right? That would be subtraction, and then they change 8x minus 2x to 6x, and they call that substitution. But don't worry about that. I want to make it simple.
Wait, so you want us to
just, yeah, keep it, make your paper look like this. So
cross out what they're doing?
Yeah, cross out what
Pretty much just read a new one.
yeah. So if we're looking, my marker's got slippery because it's made of diamonds. Yeah. Okay. This statement to this statement, what changed? 2x was what? Subtracted. So then we write subtraction property, or subtraction suffices. Subtraction. Okay. Then what do we do to both sides, perhaps? Here? Anyone? Yeah, go ahead.
Add 5.
Add 5 to both sides. The result would be?
Addition.
6x equals 6.
6x equals 6, correct? And that would be the addition property. So, in other words, before we conclude this proof, we need to write a statement and then justify it. And then it's like, oh wait, how did you get to this? Say, oh, it's justified because we added, subtracted 2x on both sides. Then how did you get to this? We added 5 on both sides. Then what do we do to both sides? Yeah?
Division.
Division. Result would be here?
X equals 1.
X equals 1. Division. Okay, you guys, can I ask you something? I feel like it's easy for you. Is this easy so far?
Yeah.
Relatively easy?
Yeah. So wait, all the rest, the other 3 steps that they have?
Yeah, they're all substitution steps. They basically explain the idea of dividing and adding and subtracting. And they put in substitution between. Yes?
So would it be okay if you just put substitution
Where?
for like these?
No, these are not substitutions though, because these are specific math functions done. As in, how do we get from here to here? We specifically subtracted 2x on both sides. Okay, that's what we did. Substitution would be, like on your paper, it would be something like this. Instead of writing 8x minus 2x, I can write 6x, because the 2x is already here. That would be technically a substitution. But the act of introducing the 2x is a subtraction. So wait, I was getting at a point. If you feel like it's kind of easy now, could we please put that feeling in the bank? Yeah, put it in the bank. Yeah. Money. Yeah, put it in the bank, okay, because it's going to get more challenging. The reason why we start it this way is for you to get the feel. That's so much money, it's heavy. Oh, got too much. Got to open a non-profit, get rid of this money. Well, why would I want a non-profit? Because I'm all about the profit, yeah! Yes, sir. Okay. The reason we do it this way is because for you to see how to go from step to step and justify. So it's going to get more challenging, just bear with it, all right? Last proof of the day, let's do it. It's on the bottom of your sheet, I believe number 7. Okay. So we got given. All right. PQ congruent to QS. Okay. And then QS congruent to ST. Okay. Can someone read exactly what it says? If, yes.
If PQ is congruent to QS and QS is congruent to ST, then PQ equals ST.
Okay. PQ equals ST. Is that in the given, or is that where we put prove?
Prove.
It's where we put prove. Any questions about that? It's where we put prove. Feel free to ask. The reason why it's in prove is because it says then PQ equals ST. So we haven't proven it yet. All right, so let's start it up. Statements and reasons. There we go. A lot of writing in this stuff. I know, I acknowledge. Reasons. What's the first statement always in a proof? Yeah, anyone? Anyone?
Given.
Given statement. So let's write that down. PQ congruent to QS. QS congruent to ST. Given. Okay. Now let the geometric proofs reign. Here it goes. We observe in the given statement that we see congruent and congruent, but we see in the proof that it's equals. Does anyone have a general idea what the difference in similarities are between congruent and equals? Anyone? Yeah.
Congruent has to do with a line.
Okay. Versus equals. And what's equals have to do with?
Equals just has to be in equation.
Okay, yeah, pretty much there. Congruence, not only with lines, but with angles or shapes. It basically implies that this line, let's say, PQ and QS, actually, let's say PQ and ST, let's do it that way, okay? To say that PQ is congruent to ST means that this line is the same as this line. Similar to saying that this table is the same as that table, right? You wouldn't necessarily say that this table equals that table, would you?
No.
No, you wouldn't say table equals a table. Equals you reserve for numbers, x equals 4, something like that. However, to say that PQ equals ST, without the segment actually, that's basically saying the measurement of the line equals the measurement of this line segment. In other words, I could say that this table is the same as that table, but I could also say the measurement of the table, let's say 5 feet, equals the measurement of that table, let's say 5 feet. All right? So we have to actually jump, as a formality, from congruent to equals. So what we're going to write is this. PQ equals QS. QS equals ST. You have to make this jump as a formality. I understand it kind of looks weird. It's basically restating. But we need to jump from congruent to equals, right? The segments being the same versus the measurements of the segments being the same.
So is this the substitution?
It's not a substitution, I'm going to tell you what it is. Let me rephrase. The segments being the same or congruent versus the measurements of the segments being equal. Right? That's the best way I can say it. And this rule is something you'll want to memorize. Here it comes. It is the definition of congruent segments. I'll write it out, segments. Definition of congruent segments. The definition of congruent segments is, if segments are congruent, then their measurements are equal. Any questions about that? All right, you're going to see that a lot. Okay? And now, how can we jump to our conclusion? Yo!
PQ equals ST because it's transitive.
Right. Right. Any questions about that? You may ask. If you have a question, believe me, thousands of people do. Any questions at home? Just kidding, you can't hear me. Or I can't hear you. Never mind, I'm money. I can be wrong whenever I want. Yeah. Money. Down economy, not for me, baby. Yeah. I gotta pick all this money up, okay? It's a tough economy. My portfolio is hurting. Yeah. Okay, let's do it. PQ equals ST. transitive property. Okay, believe me when I say that the intro that I made today was supposed to be kind of, get you warmed up. When we do this again, it's going to be more challenging, right? But so far, I'm happy that I'm getting a good vibe. All right, any other questions? Okay. Thank you very much. Yeah, you have a question?
Do you have a tissue?
Do you have a tissue? Yeah, you want some money? Yeah, blow your nose in my $100 bill. Cash rules everything around me. Cream, get the money. Dollar bill, yo. Dum 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 boom dum 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 boom 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 boom. Okay, go ahead. Mark.